So in the last sessions, how much we have completed? We have just modified that equation number 3. What was the equation number 3? That was n plus is equal to gamma of. Voice is clear? आवाज आ रही है?
वॉइस क्लियर है सर, वो पेड नोट पेड नहीं दिख रहा।
अच्छा 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 अच्छा, हाँ वो मैंने क्या स्क्रीन शेयर नहीं करी, सॉरी सॉरी, स्क्रीन शेयर भूल गया था। नाउ स्क्रीन पैड राइटिंग पैड इज विजिबल?
यस सर।
ओके, सो लास्ट सेशन में अपना यहाँ तक हो गया था. सो दिस वाज द एक्सप्रेशन नंबर 3 फॉर n प्लस. what is n plus? What is n naught? N naught is representing the, बताइए कोई बताओ यार. अच्छा, what is gamma? Gamma is known as the townsend secondary ionization coefficient. सारी टर्म्स मैंने लिखवा दी भाई, n नॉट n प्लस, ये सब चीजें क्या है इसको ना रिकॉल करते रहो ना. जैसे अल्फा वगैरह हो गया अपना, प्राइमरी हो गया, गामा हो गया, सेकेंडरी हो गया. सो दिस वाज द इक्वेशन n प्लस इज इक्वल टू गामा n नॉट माइनस ऑफ गामा n प्लस. इससे अपन को n प्लस की वैल्यू निकालनी थी. ओके, सो n प्लस विल बी इक्वल टू गामा ऑफ n माइनस n नॉट 1 plus gamma. This was our equation number 3, and now we are going to substitute this equation number 3 in equation number 2. What was the equation number 2? Equation number 2 was n is equal to n naught plus n plus e to the power alpha d. Okay, this was equation number 2. So now substituting equation number 3 in equation number 2, and we will modify the equation. What we will get? n is equal to n naught plus gamma of n minus n naught divided by 1 plus gamma whole bracket e to the power alpha d. यहाँ तक अपना हो गया था, राइट? यहाँ तक हो गया था. So from this equation, let's arrange this equation now. Let's arrange this equation mathematically only. We'll arrange this equation mathematically, and we will attain some values. चलो बढ़ाओ इसको आगे.
R&D सोलर थर्मल.
बढ़ाइए आगे इसको आगे. कैसे करेंगे? n is equal to n naught प्लस, अंदर मल्टीप्लाई कर रहे हैं डायरेक्ट है ना, बस सिर्फ मैथमेटिकल इक्वेशन है. गामा n माइनस गामा n नॉट डिवाइडेड बाय 1 प्लस गामा और e टू द पावर अल्फा डी. तो भाई ये पॉजिटिव वाला इस नेगेटिव वाले से, पॉजिटिव और नेगेटिव दोनों आपस में कैंसिल हो जाएंगे. n इज इक्वल टू n नॉट प्लस गामा n डिवाइडेड बाय 1 प्लस गामा e to the power alpha d. Finally we will get the equation. Finally we will get the value of n. Finally we will get the value for n. Okay, now cross multiply it. How many students are present in the session? There are 4 students only. Okay, जो usually रोज आते हैं. क्रॉस मल्टीप्लाई करो. क्रॉस मल्टीप्लाई करने पे 1 प्लस गामा इज इक्वल टू e to the power alpha d plus gamma n e to the power alpha d. Now let's solve it further. Gamma n minus gamma n e to the power alpha d, that will be equal to n naught e to the power alpha d. N plus gamma, this is gamma. Okay, n plus gamma, n minus n e to the power alpha d बचा, that will be equal to e to the power alpha d, n not e to the power alpha d. Now n plus अंदर मल्टीप्लाई कर दो इसको, गामा 1 माइनस e to the power alpha d will be equal to n not e to the power alpha d. सिर्फ मैथमेटिक्स है ना, समझ में आ रहा है ना, कॉम्प्लिकेटेड तो नहीं है. यस सर, नो सर, कोई सुन रहा है कि नहीं सुन रहा है मुझे यार?
यस सर.
ओके, इसको फिर फर्दर और थोड़ा सा मैंने n को बाहर निकाल लिया अपना, राइट, और ब्रैकेट्स सावधानी पूर्वक लगाना है. You should put all the brackets, all the symbols, plus minus carefully, and this is a simple mathematics. इसमें ज़्यादा कुछ समझाने की जरूरत नहीं है. n is equal to n naught u to the power alpha d divided by 1 plus gamma. इधर आ जाएगा 1 minus e to the power alpha d. So in the same way, अब ये इक्वेशन किसको रिप्रेजेंट कर रही है? दिस इक्वेशन इज रिप्रेजेंटिंग नंबर ऑफ इलेक्ट्रॉन्स. ओके. Now in the same way you have to write the equation for current. Now in the same way you have to write the equation for current. I is equal to I naught e to the power alpha d divided by 1 plus gamma e to the power alpha d minus 1. Okay, now let's move on to the this was the this is the condition for Townsend secondary ionization coefficient. Okay, please write all these equations of by primary ionization coefficient और secondary ionization coefficient. अब देखो full chances है कि जो एग्जाम तुम लोग की हो, पता है ना, फिर अब हो सकता है कि एग्जाम, समझ रहे हो? हेलो.
यस सर.
विजेता, माहिनूर, भारती, पुरुषोत्तम प्रेजेंट होना क्लास में या बस फिजिकली ऐसे ही?
Yes, sir. Yes, sir.
ठीक है. फॉर द एग्जाम पॉइंट ऑफ व्यू प्राइमरी आयोनाइजेशन कोफिशिएंट और सेकेंडरी आयोनाइजेशन कोफिशिएंट दोनों इंपॉर्टेंट है. वो दो मतलब यूनिट नंबर 1 में से ये और इसके और में इसका न्यूमेरिकल आ सकता है. तो डेरिवेशन प्लस न्यूमेरिकल. डेरिवेशन आप लोग अगर ध्यान से कर लोगे अच्छे से, देन यू विल गेट द फुल मार्क्स फॉर दैट लॉन्ग आंसर टाइप क्वेश्चन. Okay, now let's move on to the maximum breakdown condition. Maximum breakdown condition. So maximum breakdown condition for or how do we explain maximum breakdown condition by using Townsend's theory? How we are going to explain maximum breakdown condition. Maximum breakdown condition. How we are going to explain maximum breakdown condition using Townsend's theory? क्या होती है ब्रेकडाउन कंडीशन? क्या होती है बताइए? See, everybody knows the Townsend's current growth equation. Everybody knows the Townsend's current growth equation. And what about the secondary ionization? अभी थोड़ी देर पहले अपन ने किया. Secondary ionization that is given by I is equal to I naught e to the power alpha d upon 1 plus gamma e to the power alpha d minus 1. Let me mark this equation as equation number 1. So now we are going to apply the breakdown condition. So then what we can do is how to apply the breakdown condition. थोड़ा सा दिमाग लगाओ यार, कोई बताओ. So what we can do is we'll put this denominator tends to 0. We'll put this denominator 1 plus gamma e to the power alpha t minus 1 will be equal to 0. See, by applying the breakdown condition, what we will do? 1 1 माइनस गामा। अच्छा ये ऊपर की इक्वेशन ये गलत हो गई ना, दिस इज 1 माइनस गामा, 1 माइनस गामा, क्योंकि अपन -1 उधर ला रहे हैं ना, जब इलेक्ट्रॉन्स के केस में 1 प्लस गामा 1 माइनस ई टू द पावर अल्फा डी था ना, और ये अपन ने किया है 1 प्लस गामा ई टू द पावर अल्फा डी माइनस 1। ओके, सो 1 माइनस गामा e to the power alpha d minus 1, that will be equal to 0. This is the condition for maximum breakdown. We'll put this denominator will tends to 0. So now by rearranging this equation, gamma of e to the power alpha d minus 1, that will be equal to 1. That will be equal to 1. Now look at the now look back this equation. This gamma is Townsend's secondary ionization coefficient. This gamma is Townsend's secondary ionization coefficient. Alpha is the primary ionization coefficient. This gamma is the secondary ionization coefficient. Alpha is the primary ionization coefficient. And what is this d? What is this d? This is the distance. This d is the distance, or the gap between the two electrodes where you are going to fill the gaseous medium. In these two electrodes, we are going to fill this the gaseous medium. What the type of gaseous medium? That is the vacuum, air, or SF6. These are the some of the examples which we are filling in the between the electrodes, the gaseous medium. Right? This thing I have explained you earlier. So this is the distance between these two electrodes. So what you can do is look at the equation. We come to know that the value of this e to the power alpha d is too high. Or compare it with 1. This e to the power alpha d, compare it with 1. So this e to the power alpha d is very much greater than 1. So we can conclude, or by the conclusion we can say that e to the power alpha d is too larger than 1. E to the power alpha d is too large, that is larger than 1. So I can write gamma e to the power alpha d, that will be equal to 1. This is the condition. And this condition is known as the breakdown condition of gaseous dielectric material by using Townsend's theory. This is the condition, and by this condition, this is known as the breakdown condition of gaseous dielectric material by using Townsend's theory. So that means it is based on Townsend's theory. It is based on Townsend's theory. Okay, so at the time of interview, they may be asking, or at the time of exam or Viva exam, if you are having any Viva exam of high voltage or power system, they might be asking about this breakdown condition. So you can derive or explain the breakdown condition of a dielectric material or gaseous dielectric material by Townsend's theory. You can easily derive this condition, because first what we have to do, first we will write the current growth equation, later put the denominator equal to 0. Okay, first after putting the denominator equal to 0, finally apply the condition, and at the end you can write gamma e to the power alpha d, that will be equal to 1. Okay, that's the maximum breakdown condition, and we can easily derive it. Right? Everybody is getting my point, what I am trying to explain. समझ में आ रहा है भाई लोग, आप लोग? हेलो?
Yes, sir.
ठीक. Okay, so we can easily derive it. Now we will conclude after this. There is one small topic. Let's move on to that also, and it is also very important. If collectively, if you are asked in the exam that write the drawbacks of the write the drive the primary ionization coefficient and secondary ionization coefficient of Townsend's theory, and also write the limitations and drawbacks for it with the मैक्सिमम ब्रेकडाउन कंडीशन. अगर इस तरह से पूरा क्वेश्चन अगर बनता है, मतलब थोड़ा सा फ्रेम करेंगे इस क्वेश्चन को कि कैसे बनना है, तो आपको साथ में अब जैसे बैकग्राउंड कंडीशन हो गया, प्राइमरी हो गया, सेकेंडरी हो गया, आयनाइजेशन कोएफिशिएंट अल्फा और गामा दोनों निकाल लिए ना अपन ने, राइट, और ब्रेकडाउन कंडीशन भी होगी, तो फिर साथ में जब उसको एंड अप करेंगे अपन, तो वी हैव टू go for drawbacks or the limitations of the Townsend's theory, right? So drawbacks or limitations are also important. uh, it's it's just like a finisher move. If we are finishing something, it's like a finisher set, right? So now let's move on to the drawbacks and limitations of the Townsend's theory. Please write down the heading: drawbacks and limitations of drawbacks and limitations of Townsend's theory. कोई ट्राई करने चाहेगा कि क्या ड्रॉबैक हो सकते हैं? How many people are there in the class? So, there are 9 people in the class. टाइम से आ जाया करो यार तुम लोग. चलो, तो what are the drawbacks? Drawbacks or limitations of Townsend's theory. Let's list out the drawbacks and limitations. Okay. So the first limitation is see, we have wait. चुप करा दो. बाहर के शोर हो रहा थोड़ा ज्यादा, बोल देते हैं. चलो ठीक. So let's list out the drawbacks and limitations. So what? Let's move on to the first limitation. And we have already seen that in the Townsend's primary ionization coefficient, in the Townsend's primary ionization coefficient, alpha is directly proportional to electric field and inversely proportional to pressure. This was the thing. ध्यान है किसी को? Alpha was directly proportional to electric field and that was inversely proportional to pressure. This thing we have seen in the previous lectures. Anybody had remembered this thing?
Yes.
Okay.
Sir.
So अभी ये वाली जो चीज थी जो टाउनसेंड ने बताई थी, तो जो टाउनसेंड ने बताई थी ये वाली जो चीज, तो इसमें क्या है कि जो साइंटिस्ट था टाउनसेंड, Townsend was not able to give the suitable explanation for this. Townsend was not able to give the suitable explanation for this. Suitable explanation for this. Okay, so that was the main drawback was found. So there was no further explanation scientifically. Scientifically, it was not explained how this alpha is the inversely proportional to pressure or the directly proportional to electric field. Townsend was unable to explain it suitably, right? So further scientifically, it was not explained. So this is the one of the limitation in the Townsend's theory. And if we go for the next type of the limitation, we can say that this theory is applicable only for uniform electric field. Is applicable only for uniform electric field. It is applicable only for uniform electric field. So that is not acceptable for all the cases. Okay. If we are not having the uniform electric field, then what we are going to do? So this is one of the drawback, that is drawback or limitation that is in the case of Townsend's theory. Now let's come to another drawback. There's another drawback. In this drawback, the scientist Townsend made a lot of assumptions. What are those assumptions? And those assumptions are not appropriate also. Townsend had made lot of assumptions. Townsend made lot of assumptions. Okay. So those assumptions are not appropriate. It's another drawback of Townsend's theory. And moreover, there the dialectic breakdown that is generally depending upon the one more drawback, the dielectric breakdown that is generally depending upon the shape of the electrodes. Shape of the electrodes. Am I audible properly? आवाज मेरी सही से आ रही है?
Yes, sir.
Yes, sir.
So shape of the electrodes. So dielectric breakdown that is generally depending upon the shape of the electrodes, also the nature of the electrodes, nature of the electrodes, temperature के ऊपर भी depend करता था, फिर humidity. So those are the parameters. This temperature, pressure, humidity, etc. These are the parameters. Many parameters are influencing on the dielectric breakdown. Okay, many of the parameters like this shape of the electrodes. Why this is depending on the shape of the electrodes? This is not at all acceptable. How the shape of the electrodes are going to affect the dielectric breakdown of any gases, right? So these are the assumptions which are made by Townsend, and वो scientifically मतलब बाद में मतलब proof नहीं हो पाए. Okay, humidity, pressure, many parameters which are influencing on the dielectric breakdown. But unfortunately, this theory was not able to cover those drawbacks. Okay, so these are the few limitations regarding this theory. Okay, if there are few limitations, but there are a lot of advantages also. There are a lot of advantages also. That's why we are studying this Townsend's criteria, right? What are the advantages? What are the advantages? There are a lot of advantages also. Advantages point of view से अपन ने क्या क्या समझा अभी कि भाई टाउनसेंड की इतने दिन से पढ़ रहे हैं अपन. एडवांटेजेस पॉइंट ऑफ व्यू से क्या इंपॉर्टेंट हो सकता है बताइए. Yes. I'll tell one of the advantages. In this Townsend's criteria, we will be able to calculate the total value of current at the time of dielectric breakdown, and it's a true fact. Dielectric, okay, we will be able to calculate the total value of current at the time of dielectric breakdown. Able to calculate the total value of current at the time of dielectric breakdown, right? And it's a true fact. But in parallel, there are a lot of drawbacks which we have already identified. Parallelly, there are a lot of drawbacks also. If it is an advantage, then there are parallelly a lot of drawbacks also. So please write all these things what I have narrated you. The derivation, limitations और maximum condition जो कई सभी लोगों के पास में होना चाहिए, right? When we are submitting the assignment, अभी जैसे unit number 1 complete होगा, I'll open the section for the assignment. Then everybody have to ठीक है, समझ गए आप लोग? Everybody have to submit the assignment on time, right? So let's conclude the session. What we have seen, the first drawback was alpha is directly proportional to E by T, but there was no explanation for it. It was this first conclusion. Finally, this theory is only applicable for uniform electric field. Yes, this assumption, this is the second assumption. Okay, second assumption or second drawback. Okay, Then assumptions which have been made that are not appropriate. Assumptions which are made that are not appropriate, and finally the dialectical breakdown will be depending upon ये बताया ना मैंने, shape of the electrodes, nature of the electrodes, temperature, humidity. So this is also a drawback because the dialectical breakdown will totally depend upon the shape of the electrodes, nature, etc., temperature, humidity. Okay. So Townsend was not able to concentrate on this parameters. Although we have got so many advantages of it, and one of the true advantage was we will be able to calculate the total value of the current at the time of dielectric breakdown, right? Okay. जितना बोला मैंने समझ में आया भाई हम लोगों को?
Yes, sir.
शिरीन, हर्षित,
Yes, sir.
Yes, sir.
आ रहा है सर? थोड़ा बहुत नोट डाउन करते जा रहे हो कि नहीं करते जा रहे हो इस वक्त में आप लोग?
कर
ठीक.